So there are three periodic trends you need to know for your course. The first is atomic radius, the next is electronegativity, and ionization energy. You should know the definitions of all three of these terms, as well as how they vary moving across the periodic table of elements. So the first one, let's talk about atomic radius. This is a measure of an atom's size, so big atomic radius means large atom. And there's two things you need to know. So moving down a group from top to bottom, periodic table, atomic radius is going to increase. You're increasing the number of electron shells, and so atomic radius, the size of the atom, is going to increase. And that's fairly straightforward. As I mentioned, as you add more electron shells, size of the atom increases. What about moving left to right? So as you move from left to right, you're not adding an additional electron shell, but what you're doing is increasing the nuclear charge, right? The number of protons increases moving from left to right, all right? And so it turns out that moving across a period from left to right causes the atomic radius to decrease. So moving left to right causes the size of an atom to become smaller. And the reason is because the nuclear charge increases moving left to right. And this nuclear charge we also write as ZF. So ZF stands for effective nuclear charge. And it's basically the idea that the more positive charge you have in the nucleus, the more strongly they're attracting electrons in the orbits around them, pulling them closer, causing the atom to become smaller. All right, so this is important to remember. So in general, the largest atoms are going to be down here. So as you go from top right to bottom left, atomic radius, or AR, increases. So the next periodic trend is electronegativity. It is a measure of how much an atom wants electrons, so affinity for or attraction to electrons. Now moving down a group, electronegativity is going to decrease, okay? So it's going to decrease, all right? So basically, things at the top of the periodic table want electrons more than things in the bottom of the periodic table. And the reason is because of electron-electron repulsion, right? So if I were to draw an element with fewer electron shells and compare it to one with more electron shells, which one do you think is more attracted to electrons? The one on the left or the one on the right? Well, it would be the one on the left because there's less electron-electron repulsion, right? Electrons in these orbitals are pushing away against each other, and there's more electrons in the atom that's larger. So it's pushing away more of the electrons, and it doesn't want it as much, so the electronegativity of the larger atom is going to be less. So there's similar logic to, we can apply similar logic to this example. So moving across a period, electronegativity is going to increase. So electronegativity increases, here it decreases. And you should also be able to rationalize this. Similar reasoning as before, higher effective nuclear charge as you move from left to right, it increases the attractive force of the proton. The proton has a larger attractive force. If you can imagine, let's say, an atom that has a nuclear charge of +4 versus a nuclear charge of +5. This guy's going to pull the electrons a bit closer. Here the electrons are a bit further out. And the guy with a +5 charge is going to want electrons more, so the electronegativity is going to be higher. Right? So in general, as you move from the bottom left to the top right, your electronegativity, En, increases. Right? And the most electronegative element is actually not helium, it's fluorine, because there's sort of the exception of these noble gases right here. So the group 8, that last column right here, the noble gases, it turns out they are actually not electronegative because they already have a full octet. They're what we call closed shell configurations. So they're already happy. They have all the electrons they want, so they don't want any more. So these actually have low electronegativity even though they're the right side of the periodic table. All right, and the last periodic trend you should know is ionization energy. Basically, it's how much energy you need to remove the outermost electron. So the higher the ionization energy, the more energy required to remove that electron. So high ionization energy means it's hard to remove that outer electron. So as you move down a group um, from top to the bottom, your ionization energy is going to decrease. Okay, it turns out actually that ionization energy follows the same trend as electronegativity, right? And sort of for the same reason as before. There's increased electron-electron repulsion as you move down the periodic table, and because of more electron-electron repulsion, it's easier to remove the outermost electron because the electrons closer to the nucleus are essentially pushing away those outermost electrons. Um, Same logic as before, moving across a period from left to right, ionization energy is going to increase. It's harder to steal the electrons because of the higher nuclear charge in the middle, which is pulling the electrons toward it. So higher nuclear charge increases attractive force for electrons, making them harder to remove. So to summarize here, as we move from bottom left to top right, our ionization energy is going to increase. And specifically, this is the first ionization energy. You might see the term second ionization energy, which basically means how much energy is required to remove the second outermost electron. So after you remove the outermost electron, how much energy is required to remove the secondmost one? It follows the same trend as ionization energy. What you should know is the first ionization energy is always smaller than the second ionization energy, right? Because the second ionization energy is removing an electron from an atom that already is electron deficient, which is always going to be harder. It's always easier to steal the first one, and it's harder to steal a second time. Okay, so that's the three periodic trends you should be familiar with. Atomic radius, electronegativity, and ionization energy. You should memorize these.